Hi Spring fans, welcome to another installment of Spring Tips. In this installment of Spring Tips, we're going to look at the new Micrometer framework. Right, so Micrometer is another project. It's a project that's independent of Spring that has been led by Pivotal, but of course it's an open source project, and so enjoys contributions from a lot of different groups who want to make this the best tool for their particular use case. It is meant to be a vendor-neutral application metrics facade, and I really quite like this description here because it's quite fitting. It's like SLF4J, but for metrics. The goal of this framework is to capture metrics and to publish them to time series databases and monitoring systems, things like Prometheus and Netflix's Atlas and Signal FX and Wavefront and CloudWatch and Datadog and Graphite and Ganglia and JMX and InfluxDB and New Relic and StatsD, etc. So a lot of different time series databases, and these databases are optimized for managing keys and values. A key that you can then ascribe a number to, and the whole history of that number. So you can use these tools to graph the trend of a number over time. You can see, for example, the peaks and valleys. You can query that to see derive information, derive insight rather from the numbers, and then to use that insight to drive change in the code. And you can also use it for alerting. You can use it for all sorts of things when it comes to your application's health, and a lot of people turn to time series databases and monitoring tools like this to understand latency, to understand how information is performing, how certain parts of the application are performing, and so on. Metrics are meant to capture the aggregate, the sort of the aggregate state of a particular exchange, for example, not to capture individual exchanges, right? So if I want to understand, the average latency for a call to an endpoint, then this is a great tool to use for that, because I can sample all the different requests that have gone to that endpoint, and I get a number, and then I can sum those up together, divide by the number of samples, and then there you go. That's my my average, for example, right? And I can also use statistics to look at all the numbers and arrive at things like the 95th percentile, the median, right? All these different interesting numbers that I want to understand when it comes to latencies. If, however, I want to look at a particular exchange as concerns me, Josh, that I made on the website, a week ago, and I want to see where that request went and how long it took and so on, then this is the wrong tool for the job. In that case, you'd use distributed tracing. So metrics are good for sort of aggregate, big picture sort of numbers, and they can help you understand the movement of data through the system, and they can help you understand all sorts of other things related to your application's state, right? So it's very important to have these kinds of systems in your organization, and a good platform, of course, like Cloud Foundry, will stand up and support these metrics automatically out of the box. So if you're using Cloud Foundry, there's a Meter Registry implementation there that Micrometer will automatically integrate with. So a lot of different ways to use this. Now, this project is not, as I say, it's not part of Spring. It's a separate project that can be used independent of Spring. A number of different projects are already supporting it out of the box, including, for example, Hikari CP. I think I saw that they're going to have Micrometer metrics publication built into the code itself. The RabbitMQ Java client will support this. I mean, we're seeing more proliferation of Micrometer in different Java projects. It is being used like SLF4J or Log4j or some sort of library like that, where it's just embedded and you just have to work with it. It'll be a common sort of currency for this kind of use case. Now, why this? Why Micrometer instead of something like, for example, Dropwizard metrics? Well, the answer is, first of all, in some cases we're still using the Dropwizard metrics library, but the larger answer is that this supersedes the Dropwizard metrics library because it supports dimensional metrics. Right? This is the big thing right here. The biggest feature here is this idea of dimensional metrics. So when we talk about dimensional metrics, we need to distinguish that from hierarchical metrics. So let's say I open up this file here. Okay, so now let's say I want to capture all of the HTTP requests. So I'll say http.requests. This is a hierarchical metric, right? I can capture this, and each time there's a new request, I can +1 that count, or I can keep the duration of that or whatever. Well, let's say I also want to now capture all of the requests that were HTTP GET, and I want to also distinguish that from all those that were HTTP POST. And let's say I also want to get, I want to also distinguish that from the those requests that had JSON. So I have to now add JSON versus XML, right? And then let's say I also want to capture the region, right? The region in which the request was made. You know, the which instance of which servers got them. Maybe I've got servers in different cloud provider regions, like US East and US West. So I can say US. Let's see, what's the right way to do it? I guess I can say US East, right, down here as well. And this might be US West. So it gets very tedious to break these apart. And ideally, I'd have to maintain, you know, to be able to most efficiently query this kind of data in a non-hierarchical system, I'd have to maintain different counts, right, different numbers, different metrics for all of this to be able to drill down. So I'd have to say, here's the count of all those that were posts and JSON. Here's the count of all those that were in US West that were posts and JSON, right? So it gets very hard to, there's a proliferation of services, of metrics that it becomes hard to manage. Now, what if instead you could say, okay, I'm going to have one metric called HTTP requests, and I'll have tags that give me extra information. They enrich the metric, but they aren't the metric themselves. Things like, oh, the region is US East, and the method is get, and you know, the content type is whatever. I mean, you know, JSON, right? So you can do all sorts of things there, and in a hierarchical system, it's not as easy to kind of model this kind of complex multi-dimensional data, and it's certainly not as easy to query it. Well, a dimensional data, you know, time series database like Netflix, Atlas, and Prometheus will make querying and interacting with this kind of data a breeze. So we support that with this API where appropriate. Now that said, some systems like JMX don't support that. And you'll find that Micrometer actually delegates to, in this case, the drop wizard metric support for JMX. So with that in place, with that basic understanding of the distinction, let's go ahead and build an application. I'm going to go ahead and build an application as usual by going to start.spring.io, and we'll build a new application here that uses Spring Boot 2.0 and the Actuator. We'll use H2, JPA, the web support, and Lombok. Okay. Now I'm going to call this demo Micrometer, and we're going to hit generate, and that'll give us a new project, and we're going to open this up in our IDE as always. And this project is going to we're not going to actually use all those things. We're not going to build a web app or talk to, you know, to JPA or to a data source. I just want to demonstrate that this stuff is all automatically instrumented for you. So before we get into that, though, let's look at the API, the Micrometer API, independent of Spring Boot. So just for now, ignore the fact that this is a Spring Boot application. Let's suppose I have this endpoint here, and we'll create a new endpoint. We're going to create a new Micrometer project independent of Spring Boot. And the way you do that is you use a meter registry. The meter registry is the heart of the API. Now, in the Spring Boot world, this will be automatically configured for you, so you can just inject it anywhere you want. There are different implementations of meter registry. You can see that we've got a composite meter registry, a simple meter registry, a step meter registry, etc., and a drop wizard meter registry, which is just an adapter. So we're going to use a composite meter registry, and the composite meter registry then has a chain of other meter registries, and these are registry-specific adapters, if you will. So here, I'm going to say, let's use Micrometer registry Prometheus. And the version, of course, will be micrometer.version. This is the property that's in Spring Boot. So all of this is, you know, being managed for me by Spring Boot, thankfully. Don't have to manage that. And I'm going to use JMX as well. So I have JMX and Prometheus. And what I'm going to do is I'm going to say to the registry, I'll say meter registry.add new JMX meter registry, and I can configure the config, but I'm not going to bother running this code. I just want you to see kind of what's happening here. New Prometheus meter registry, null again, right? So now we have two different registries. Now we can use it in terms of the meter registry interface. So meter registry, mr equals meter registry. And we can say mr.config. We can configure things that are common to all filters, to all metrics in the system. We can say common tags, for example, equals, let's say region. Let's say I want to resolve that property, get the property here from, you know, cloud region, right? There we are. So I'm pulling in that region property from the environment variable, and that's going to preface, it's going to be a dimension, it's going to be a tag that's going to be added to every single metric that gets collected in this application. Once I've done that, I can now start collecting metrics using different types of meters. And at the top level, using the meter registry type, there are three types of meters. There's a counter, which is a number that increments, decrements over time, so stepwise, +1 or +10 or +5. So orders placed, and I can then increment it, or I can increment it by, whatever. I can or just increment it by 1. I can also increment it by negative 123, right? I can do decrements in that way. I can create gauges. A gauge is a thing that has a bounded value. So a common example is the gauge for speed in the car. The speedometer will show you that you can go from 1 to 120, for example, 120 miles per hour here in the States, and that's a bound. It's an upper bound. Your car is electronically limited or mechanically limited in some way, so as to stop you from going any faster than that. The result is that whatever speed you're going, it's going to be some number in between 0 and that upper bound. So a gauge is a great thing if you're just trying to capture the fluctuating state of a number in that range. Okay, so speed could be, I'm going 12 right now. I could be going 55, whatever. So I can capture that over time. Each time I capture this, it'll be recorded in the time series database, right, or in the registry of some sort. And then finally, we have a timer. And timers are, for my money, are the most useful thing we can get out of a metrics tool like Micrometer. So here I can say how long it takes to process a job. So transform photo job. And here I can provide tags. I can do it if I want, but I can also say record the duration, right? I can give it a duration. I can say record this hard-coded duration. It can be, 12 milliseconds, right? I could do a recording with a runnable, right? So some very convenient ways of getting that data there. I can say, do something expensive and slow here. If I want to get the result value, if I want to get the return value out of this processing, right? Like system out print hello world. Let's say instead of printing out the hello world, let's say that I want to I want to return hello world. Instead of doing that, I can say that I'm going to use a new supplier. So a new supplier of type string, and I'll return hello world, and the result is now given back to me here on the other side. So there's the greeting, here. So greeting hello world, and however long it took me to create that, I could imagine doing some work or something, doing work, and then it'll take some sort of time, and then that's what's recorded. And there's there's lots of nice overloads here that you can use. There's overloads also for gauges, right? I actually showed you how to capture a fixed number here, but one of the most interesting ways to capture a gauge is to give it a function, right? So instead of me giving a hard-coded number every time, I can just give it a function so that it, whenever it's asked, can produce the latest value. So let's say I have this method. Let's say I have a class, stateful, slow, stateful thing, right? Okay, and it has a what's a good way? Let's say I have a number of customers, right? So public int get customers logged into system, right? Here I can retain math.random is going to be the times 1,000, whatever. I'm just producing some random data here. So int, or even better yet, let's just do new random dot next int. All right, and can I do that? Is that a upper bound? I think. So let's say I have this bean. I have a type of slow stateful thing somewhere, and I know that I can ask it for how many customers I have in the system, right? So customer service new slow stateful thing. And now later on I want to have a gauge that keeps track of that for me. So I can say gauge customers logged in, pass in a pointer to customer service, and give it a new two-double function. And here I just say let's call customer service dot get customers logged in. So I actually have this convenient little lambda. I'm actually giving it a pointer to whatever. It's going to keep that reference for me, and it'll pass it as an argument that I can use in this lambda, and then I can use that. So I can say slow, right? That's what I've been given in this case. And of course, this could be a method reference, right? I could just say slow, Here's the pointer to the source stateful thing. With that pointer, call get customers logged into the system and record that value. So it's going to, whenever it needs that number, whenever it's trying to publish or synchronize these metrics to our backend registry, it'll call that for us. We don't have to constantly contribute to it. So if we have some things that are just kind of off on their own, updating their own state, then this is a great way to sort of capture that, okay? So a lot of different overloads here, a lot of very convenient ways of thinking about the metrics. Now, let's go ahead and use this all in terms of Spring Boot, okay? So let's go ahead and bring back Spring Boot and look at what Spring Boot gives us. We have now just a, very basic Spring Boot application. All right, good, very good. And I'm going to create a simple bean. That's an application runner that's going to take advantage of a executor service, scheduled executor service, and it's going to be executors.new scheduled thread pool 1, and we'll use that. We'll say return args, and we're going to use that to schedule some work. So this dot scheduled at fixed rate, and we're going to create a new runnable, and we're going to run it every 500 milliseconds using with a gap in between of 500 milliseconds. So it'll start off after 500 milliseconds, and it'll then run every 500 milliseconds. And if this takes let's say 600 milliseconds, then indeed the second one will start before the first one has finished. So if you're doing a fixed rate, then you want to make sure that you finish. You don't want to get it all bunched up on itself, right? You can do schedule at a fixed scheduled fixed delay rate. I think the delay one is the one that avoids the it gets staggered, right? It gets staggered out so that one finishes before the next one starts. So you want to be aware of the difference there. I think I have the right one in this case, but in our case, it doesn't really matter. We're just going to publish a metric so we have something to work with. So what I'm going to do is I'm going to publish a metric here using the meter registry. So I'll inject that here, and we don't have to configure, right? That's a nice thing. It's Spring Boot, of course. So Spring Boot automatically can configure a composite meter registry, which itself has access to the JMX and Prometheus meter registries, and that all is done for us automatically thanks to the presence of these libraries on the class path, these dependencies. So now we can say meter registry, and what I want to do is I want to use a timer. Okay, so I'm going to create a timer. Let's say I'm doing some sort of job that takes some time. So transform photo task. Okay, and I want to record a metric here. So I'm going to say that I want to record a duration. So duration of milliseconds, and so I'm going to give it some milliseconds. And I'm gonna, I suppose I could just do this randomly. So, new random dot next int, and what is the int? I think the int is the upper bound. Is that right? Next int. Is that the seed? No, it's not. It's So what do I do? I want to just multiply it. So int r equals. Okay, I guess I can just do math.random just to be sure. So math.random times 1,000. All right, so I'm going to save all of that. And we'll say long R, and I'll give it a long, okay, R. So sleep. Okay, so I'm going to say that this job is taking so many seconds. This is a millisecond, so maybe it should be, it's not a very lot. It's not a lot of time either way, but whatever. We'll have some number, presumably greater than 0 and less than 1,000, and we're going to sleep. We're going to have that. We're going to register different timings that reflect this duration. Okay, it's artificial because I don't want to actually sit here and wait that long. And there's my updated code. Now, this is going to run. It's going to register metrics. I'm going to see those metrics reflected in the running system. So that's one option. I want to see this information in the application, the Spring Boot application, as part of the actuator. So I'm going to go ahead and say I want to expose all of the metrics, all of the endpoints, all of the actuator endpoints. I could just say show me the health, metrics, but I want to show all of them, and then I'll restart the application with this code in place. And we'll see that Spring Boot does all the work for us, right? We've already got this endpoint up and running. So localhost 8080/actuator, and we go there and we can see a number of different endpoints, and that's we could have a whole other show on these different endpoints, but let's look at the metrics endpoint here. Click on metrics, and we can see all these different metrics that have been calculated and computed for us automatically by Spring Boot. Things like the logback events, the JVM information, by the way, that was inspired by, for example, what the Spectator library for Netflix Atlas and so on does behind the scenes. So all this stuff is like, battle tested, field tested techniques for getting insight into what the JVM is doing. All that is reflected here. And we have things like the Tomcat state, the JVM threads, liveliness, classes loaded and unloaded, Hikari CP connections, cache accesses, all the kind of stuff that you would want, including our custom metric, which is transform photo task. And if we look at this, you notice that this endpoint is a little different than what we had before in Spring Boot 1.5. So again, what's happening in Spring Boot 2.0 is we've deprecated the counter servers and the gauge servers and all those things from Spring Boot 1.x. That's all gone. You can use Micrometer instead. That's we consider that a superset, a superseding sort of introduction. That said, we don't want people to feel like they have to jump to 2.0 to be able to use Micrometer. So there is a bridge library that you can use with Spring Boot 1.x that will allow you to use Micrometer in those older environments. And it's also, it's important to understand that while we're no longer, while we don't particularly recommend drop wizard metrics anymore, we still use it in some cases. So I did mention that some systems lend themselves better to hierarchical information, and one of them is JMX. So actually, if you look at this, JMX meter registry, behind the scenes, this is using the drop wizard meter registry, and it's using the JMX reporter. So a lot of different adapters here. In this case, since it's a hierarchical registry, the JMX is, and it doesn't have support for dimensional metrics anyway, why bother reinventing it, right? So we just use what works, and that's why we get this nice support there. So now we have this information in the output here, and we can look at the details here, right? So even though the endpoint is different, you can still get the details, but you have to drill down. And the reason you have to drill down is because there are different dimensions, right? So there's no tags in this one, but let's go look at one that most assuredly does have tags, which is to say, how many HTTP requests do we have? So HTTP server requests. Now this metric isn't going to be all that useful yet, right? So it's HTTP server requests. Click on that, and you can see that there's only been a few different endpoints that we've called, but and we can see the things like the count, the total time, and the max of any particular request. All that is reflected here in the statistics that are at the top. But we also have these different tags, these different dimensions that we can use to drill down. So we can say, I want to find all requests that were of type HTTP GET, right? So you can say tag equals method equals GET, and that'll show you only these requests. Well, of course, in this case, that didn't really bias anything since all requests are GET, but you can see how useful that would be to be able to drill down by tag in that way, by key value, by status, right? Or by key and key value and key and value, right? These pairs. You can drill down by status, for example. Is it 404? Is it 200? Etc. So you can do complex queries. And this is just the Actuator endpoint, right? We time series databases, tools like Prometheus will do a far better job of sort of visualizing this information. So let's talk about that. Let's look at Prometheus, which I have running in the background here in port 9090. And Prometheus is one of a sort of a new breed of time series databases. This one I think came out of SoundCloud.com. It's battle tested, works at scale. We know it works well, and Netflix Atlas is another one that's come out of Netflix, so we know again that one works well as well. So a lot of different tools here designed to solve this problem well, and this one has got a very, very sophisticated graphing subsystem, as does Atlas. So here we can look at the information related to the transform photo task, and if we look at that, we can see transform photo task. Did that code? Is that not happening every 500? Task. Prometheus transform photo task. There it is. So count, for example, execute. You can see that right now there's no differences here in the data. It's always just it's just one trend line. Let's reduce the window here quite a bit, so you can see the stair steps here. I just did it for the last minute, and those are all the different samples. Stair step there, or now it's 5 minutes. Now I want to have different dimensions here. So let's go ahead and change this data. One thing you can do to change this data, of course, is to contribute a timer using this meter registry thing here, right? This is a convenient way to do it, but there's also these builder APIs, right? So you have these builder APIs, and you can use those to do, to build up more complex kinds of contributions to the meter registry. So I can say a timer dot builder dot transform photo task. I can say that I want to support a duration, so duration or an SLA that it says of milliseconds is 1, going all the way up to of seconds to 10. So I want to support that SLA between those two. I want to support publishing percentile histograms. I want to have custom tags here, and the tags are I could configure this per metric here. I could certainly do that, right? That's a good idea. Actually, we can do that as well. So let's publish the tag here, but let's see, publish a tag of what? What is the tag? The tag will be something that will change, because it's going to be variable, right? We'll do something different here. So JPEG format, right? It can be format math.random greater than 0.5. PNG, hopefully, if the open web is anything. Otherwise, JPG, right? So there we are. So there's my custom tag, and I want to record it, register it rather with the meter registry there, and then we record it. So that's my custom built metric, and I can do all sorts of very dynamic things with these builders. There's equivalents for the counters and for the gauges, and there are even some kinds of meters that are not available from the meter registry interface that you can also contribute, that are just sort of not standard. They're not common enough that we can guarantee them across all different supported interfaces. So there's also, for example, long timer or long task timers, right? A long task timer is like a timer, except that it's meant to have a deadline. It's meant to have a time at which point the system should do alerting to say that this has exceeded some sort of deadline. So think about a timer. The timer is great for small duration jobs, like resizing a photo, for example. Well, if I have a long task timer, maybe I'm processing several gigs or terabytes of data or whatever, and the job is supposed to just take 10 minutes or whatever, and you expect that on average it'll take 10 minutes, but suddenly for some reason it's running for 3 hours. Well, would you like to find out that system has run over by 2 hours and 50 minutes after the fact, or would you like to find out as it's going over that allotted schedule? And so a long task timer can publish sort of a back channel notification telling you that something is wrong, and it can do. And a lot of these different time series databases will support alerting based on that deadline, about that on that kind of custom deadline alert, right? So you could use that as well. You should use that for longer jobs, but not all systems support that. So we don't support that. We don't surface that in the meter registry interface there, right? So you have a lot of different options here. Now, I showed you how to register a tag here, right? And earlier we looked at. Let's go ahead and restart this and get some traffic in the meantime. Earlier we looked at how we can configure things with the config method in the meter registry, and that's certainly an option, right? You can actually you can get access to that meter registry while things are being created before any metrics have been contributed using a meter registry customizer. This is a callback interface that gives you a pointer to the registry before any meters have been added to the application, or added to the meter registry. So here I can say registry.config common tags, and I can say region is going to be equal to let's say I inject the region, right? So some sort of global configuration that's unique to this node. So I'll say string region. Here I'll say it's going to be region or US West. Okay, so I'm going to use US West as the default value if the environment variable region doesn't exist. And of course in this case it doesn't exist, so it'll always just be US West for this case. And that's a very clean way to configure common things that are across all the different metrics there. Another thing that you can do very nicely, another way to change the default behavior is to configure custom properties. So I have here, for example, the management.metrics.enabled I can say all equals false. And if I do that, all is a special keyword here. It'll disable the publication and accumulation of all metrics, not just the ones that I'm creating, but all of them in the system. I can use, I can say everything that starts with JVM will be disabled if I do this, right? Everything jvm.foo.bar, everything that starts with JVM will be disabled, including jvm.foo.bar. So I can also disable, for example, HTTP, right, if I wanted to. So you can do some very kind of interesting whitelisting or white labeling or, whitelisting or of variables, for example, of properties. You can also configure custom filters and custom configurations. So I can actually say that I want, for HTTP server requests, I want to have a percentiles. I want to capture distributions of percentiles, and I want to do that for 0.5 and 0.95, right? So I can actually configure that for that metric, right? You can do this in properties in a generic way across all things, but you can also do these kinds of custom configurations using a meter filter. So here's a meter filter, and a meter filter is just that. It's a filter that gets processed. It gets a chance to run, or it gets a look at every registry, every metric that gets sampled or captured, and it's given a chance to decide whether that metric gets to be retained or if it's just ignored, basically. And when I say ignored, it means it's not collected, it's not published to the time series database or to the monitoring system. It's just kind of ignored. So I can actually be as granular as I want here. I can say I want to accept, anything that starts with JVM. Right, that's the example that we had earlier. So anything, if the name starts with JVM, ignore it, but otherwise let everything go through. So if we look at our metrics endpoint, I haven't restarted the app right now, so if we look at the metrics endpoint here, we can see JVM, like a lot of them there start with the token JVM. Let's go back and add this simple meter filter while we start the application. And no more JVM, right? It's all gone. Those metrics are just completely gone, and they're not being published to this either. So that's very convenient. You can do all sorts of interesting things with meter filters here, and you can even compose them. You can create composite meter filters and so on, or just register a bunch of them if you want. So okay, so we've got now a number of different ways to change the application, to change the defaults. The meter registry customizer is arguably the most useful way. We also have something called a meter binder. A meter binder is a interface that when Spring Boot sees it, it's part of the Micrometer API, but Spring Boot knows about it. And you're given a pointer to the registry, and you can have objects that know how to unpack information or to extract useful metrics from a different subsystem and contribute them to the registries, right? So here you might have like something that knows about data sources, as Spring Boot does, right? There's actually a data source pool metrics object, and it implements meter binder. It's given a callback to this meter registry, and it's also found out, it's also discovered all of the other data source connection pools in the application context. So it's using the fact that it's got access to both the registry and all the data sources to contribute some metrics to the meter registry that will get updated whenever the state of the connection pools changes, right? So this is a good way if you want to contribute metrics, a whole suite of metrics, and you've got some subsystem that needs to be monitored or measured. You could do that in a single place and then reuse that. Somebody else can just install the meter binder in the application context, and it'll do all the work for you. Or you could put it in an auto configuration, right? And that's a very common use case here, is to have this do the right thing out of the box. I could write an auto configuration that has custom meter binders. I could have a auto configuration that has a meter registry customizer and some meter filters, and when somebody adds that application to the class path, we're automatically making sure to measure the things that, as an organization, you've decided you want to measure. So that gets you consistency, and you get velocity through consistency, right? This is why, again, it also helps to have the support at the platform level. So Cloud Foundry, for example, will see that you're using Micrometer, and it'll auto reconfigure your meter registry to point to the platform meter registry if you wanted to, right? So a lot of a lot of value in having this stuff permeate all your code and just be something that just works. It's just everything knows about it, knows how to use it, and so on, right? And it's a very lightweight library, so it doesn't cost you anything to do that. Okay, so now we've got this custom metric, we've got this timer. It's calculating data. It's been running in the background now. So let's go to our Prometheus, and what do we say this was? This is called transform photo task. All right, so transform photo task count. And you can see there's now 4 different time series in there, broken down by the format, right? And the region, right? So you can see it says region is equal to US West, and region is equal to US West. Well, of course, that's hard-coded there. So we have all these different values here, and we can look at specific sections of them, specific dimensions, if you will. So we can say region equals US West. Well, of course, that's same as, that's 2 of them, right? That's kind of redundant. We can also say I want to look at everything it kind of equals. So I can say like this. I can do a regular expression. Dot query, enter, execute, and that'll give me that. Of course, in this case, it's everything, but you might have metrics from different regions that are all accumulated in this output here. So it would show you all the metrics that are of the form transform photo task second count, and it would show you all those that are in the U.S. But this would ignore, for example, all those that are coming from Asia, for example, or whatever. Right? You could have different metrics and different schema there. You can use regular expressions to describe that. You can do negation. So I can say, not equal to US West. Right, execute that. And that gives me these 2, right? This is, I guess these are the ones that don't match that. We can also do format does not equal PNG. Right, so there's that. So this is the data that corresponds to JPG, right? So yeah, you can do very complex querying here. You can create lots of different graphs as well, like this, and visualize them over the system, over the time, and put this on some sort of monitor of the system somewhere in your organization. So and then use it to drive a screen, for example, a monitor or something like that, or alerting, even better. So we have now we've gone very, very, very briefly over a number of features in Micrometer. We've looked at its smart automatic collection of metrics for you for things like data source utilization, random queue connection, file descriptor usage, logback events, uptime and Tomcat usage, CPU usage, and Spring MVC and web flux, request latencies. We've looked at it can support things like REST template latencies. We've also got support for capturing JVM metrics, including utilization of various memory and buffer pools, statistics related to garbage collection, thread utilization, numbers of classes loaded and unloaded. We've looked at the basic API for Micrometer, starting with the meter registry and branching out to look at the gauges, timers, and counters. We looked at how it all plugs into Spring Boot, and of course we looked at some of the automatic support that we get here for publishing of metrics. Now, we did so without kind of really touching on how Spring Boot is publishing these metrics. It's kind of interesting that in this case, we're using Prometheus. Now, Prometheus is a poll-based monitoring system. It pulls data from your service. Your service has to surface that information for it to pull. So the Spring Boot auto configuration here automatically stands up a endpoint called Actuator Prometheus. And this endpoint is in the format that your Prometheus engine is going to expect to be able to see, to be able to read the data. Now this endpoint is it's strange looking, but this is what Prometheus is expecting. Now, if you're using straight Micrometer, there's an API there that you can use that will give you a string that all you have to do is then stand it up as an HTTP endpoint and point Prometheus to it, and that'll work. But Spring Boot just does all that for you, right? So it's already done here for you, and then you have to configure Prometheus to be aware of this endpoint. So you go, for example, to your config file. I've got a config file here, localhost 8080 YAML, and I've configured in my scrape configs rather. I've got a job name Spring Boot Actuator, metrics path equals Actuator Prometheus, and the target is this host and port. Okay, so I've got now a very, very simple configuration file, and I'm telling Prometheus to pull the data from my node. And this is just one instance. I could have 5 different targets, and it would automatically pull the metrics from all 5 of those. Now, this is how you tell Prometheus to read data from my services. On the other hand, I might, for some other services like Graphite, I have to push metrics to it. So the client, that's my microservice, would need to publish his metrics to Graphite, and then Graphite has to accumulate and render them, right? There's drawbacks to both sides, right? In this case, if I'm using the pull-based system, then I don't have to have a custom library that knows how to speak to Prometheus. In Java, this is not a big deal, and in most large communities, this is not a big deal. But perhaps there's no maybe you're working in a language where there isn't a readily available client library, so you're kind of on your own to figure out the protocol to publish metrics to Graphite. Well, it turns out that Graphite uses statsd, right? Statsd or it supports statsd, and so statsd is a super easy protocol. But even there's a number of different flavors of it. There's Datadog, there's Etsy. I mean, there's a lot of different ways to get statsd data, statsd flavors, and you have to contend with that when you write a client to talk to these tools that support this flavor. And other monitoring systems have protocols that are far more sophisticated or complicated. I mean, statsd, for example, is dead simple. There's not even really a mechanism for security. You just have to funnel in a token and you have to substitute something else that would have been useful in of itself. You have to replace that and use it for a token, right? Just because there's no built-in mechanism for that. So if you're using a language and a technology that doesn't have the ability to talk to that monitoring system, and you need to do anything sophisticated, anything at all, really, then having the requirement to push metrics to that system isn't going to be great. Also, you can overwhelm that system. You might be able to send too many requests at a time. The downstream system would read the data, and it would it would try and read it as fast as it could. But if you send more than it can handle, it's going to fall over, right? On the other hand, in this case, the system is doing a pull-based. For Prometheus, it's doing pull-based accumulation of metrics. We've looked at the metrics, in the Actuator endpoint, and we looked at them in the Prometheus endpoint. That endpoint is the endpoint that Prometheus needs to do its work, and it's not such a big deal. Anybody can speak HTTP, right? So almost any language or protocol these days will have the ability to stand up an HTTP endpoint that Prometheus can then use to glom state about the application. Not a big deal, right? That's very easy. It also has the benefit of being gated by Prometheus. Prometheus isn't going to try and ingest more data than it can handle, right? It's going to hopefully keep itself alive and stop before it gets overwhelmed. So in this respect, this is, I think, a better solution for more resilient systems. But it does mean that each microservice now has to take responsibility for standing up this HTTP endpoint. So I guess the question is, do you want to take responsibility for configuring the client to publish metrics, or do you want to take responsibility for configuring the HTTP endpoint to serve metrics that can then be ingested by some sort of scraper? Either way, the code has to do something. It's just a matter of the trade-offs you want to make and the robustness and resilience characteristics that you're expecting from your system. All right, so we've looked at a number of different things. We've looked at how to configure the application. We looked at all the metrics that are supported here. We looked at a number of different ways to configure things, including the various callback interfaces and also the properties in Spring Boot. We looked at a few of the different meter registry implementations that we have here on the class path, and we talked about some that we didn't even see on the website, for example, the one in Cloud Foundry. We've just begun to scratch the surface. Obviously, this is a topic that's near and dear to my heart. There's a number of things that you can and should do to support observability in your organization, and Micrometer is a really, really powerful step in the right direction. So with that, my friends, thank you so much for watching. I hope you got something out of this, and we'll see you next time.